Welcome to my channel, The Opinionated Science Educator. To the grade 10s who are part of the pre-university academy program at Mamelodi campus, welcome. This video is part 1 of the contact session that we had for lesson 1. In this video, I'm going to recap using the PowerPoint presentation that I used with you in class, the main ideas that were covered during the session. In this first video, I focus on the definitions of a mixture, compound, and element. So let's start this recap session by doing exactly what I did with you in the contact session. If you remember, I showed you the trailer of the movie Flubber. It's quite an old movie. And I asked you, is Flubber an element, a compound, or a mixture? So let's watch the trailer and then come back to that question.
I love you with all my heart, with every molecule, with every atom. I love you on a subatomic level.
This is going to be the very last time I try to marry you.
I'd rather die than disappoint you.
On the most important day of his life, Philip Brainerd, the world's most absent-minded professor, made a few little mistakes.
Wow! What a bang!
And one gigantic flub.
Flubber! Flubber? Sounds like baby shampoo. It's a metastable compound. If you apply a small amount of energy, it liberates an enormous quantity of energy.
This destiny has applications in the field of sports.
When I exit this window, the flubber will send me right back up unharmed.
Are you nuts?
Ta-ta, my love. Ouch.
Walt Disney Pictures presents a classic story.
Oh, sorry. First time flyer.
A boy meets goo.
Get him!
This Thanksgiving, discover the stuff that dreams are made of. Robin Williams. Flubber.
But before we say what Flubber is, let's define. A mixture is made up of 2 or more different substances which are not chemically combined. A mixture is a physical combination and the properties are retained. An element is a pure substance consisting of atoms of one kind only. Chemical elements cannot be broken up, and a chemical compound is composed of identical particles of atoms that are made up of different atoms held together by chemical bonds, and they can be separated by chemical means. Now clearly Flubber is not an element, not made up of one type of atom. If you watch the trailer, you saw many different things went into that vessel from which Flubber emerged, and that included a huge surge of energy. That energy would have brought about a chemical change. So Flubber is most certainly a compound. And we also know that Flubber is a compound because it has properties that are completely different to all the things that went into making Flubber. So yes, Flubber is a compound. And the definitions that I gave earlier on, and during the contact session, many of you gave me the same definitions about compounds being made up of 2 or more different kinds of atoms and elements being made up of one kind of atom, I find slightly problematic. So let me show you why. Now look at these different pictures of different substances that I'm going to show you. Here is one. Is that a pure substance or a mixture? An element or a compound? Okay, I know that's a mixture because I can clearly see the different components and I can separate it using the magnetic property of iron. So yeah, the mixture is easy to recognize at a macroscopic level. There is a glass. Is that pure water or is it salty water? You can't tell by just looking at it. If you taste it, you will taste the salt. And once you've tasted it, you will know that it's a mixture, and you can separate it by evaporating the water off, because water and salt have different boiling points. So mixtures are fairly easy to distinguish at a macroscopic level. In other words, by the things you can see, taste, hear, or feel. But now look at these pictures. Are these elements or compounds? That white powder, element or compound? How about that yellow powder, element or compound? That gray looking substance there, element or compound? Can you tell by just looking at them? Okay, the white substance is sodium bicarbonate, so I know that's compound. The yellow powder is sulfur, so yes, I know that's an element. And that gray powdery stuff are iron filings, so yes, I know that's an element. But you couldn't tell by just looking at it, because you can't see the particles that make them up. What about that white crystal there? Element or compound? And that purplish grayish looking crystal like substance there, element or compound? Well, the white crystals are sodium chloride, so yes, it's a compound. Those gray crystals are iodine crystals, so yes, I know it's an element. But you couldn't tell that by just looking at them. How about those metallic looking rods there? Those rods and that wire, element or compound? Well, the silver rods are actually aluminium rods. The red wire is copper wire, those are elements. But the one in the middle is actually brass rods, and brass rods are a mixture, and you couldn't tell that by just looking at the substances, because you could not see the particle. So as you saw, me asking you to say whether something was a compound, element, or even a mixture is sometimes difficult, because you cannot see the particles. What you see are the substances. That is called the macroscopic level. To distinguish between an element and compound at a macroscopic level, you can't use the definition of what happens at a particulate level. So what happens at a particulate level is called the submicroscopic representations in chemistry. Now, of course, if I just given you the names beforehand, or the symbols, you would have known based on the symbolic language from the periodic table whether it was an element, and if I'd given you the chemical formula, you would have known it was a compound. That is called the symbolic level at chemistry. Grade 10s, in this course, I will always explain chemical concepts at the 3 levels of representation. Now let's look at how we classify substances. If you have mass and take up space, you are matter. So anything, the desk, your clothes, the smog, water, even you are matter. Now matter can be classified either as a pure substance or it is a mixture. Mixtures are either homogeneous mixtures or they are heterogeneous mixtures. Pure substances are either elements or compounds. Thanks for joining me for part 1. In part 2, we're going to look at how we can classify substances as mixtures, elements, or compounds by looking at the particulate nature of matter. So, until then, this is the Opinionated Science Educator, signing out.